Finally, the last type of transformation we'll be studying for this year is the dilation. Dilation is when something gets transformed and the resulting image is either bigger or else smaller than the original. This picture of two giraffes here I thought was a pretty close version of what might be a dilation. A better example might be something when you photocopy something and either shrink it or enlarge it so that the image looks just like the original except it's smaller or bigger. Here's some vocabulary. So dilation is a transformation that stretches or shrinks. I like to use the words enlarge or reduce a figure to create a similar figure. Notice that it's a similarity transformation. It does not create congruent. It does not create congruent images. In a dilation, a figure is enlarged or reduced with respect to a fixed point called the center of dilation. The only center of dilation that we'll be using will be the origin. It just makes everything a lot easier to begin with, because that's how we start with everything, is make it easy and then make it harder later. The scale factor of a dilation is the ratio of the side length of the image to the corresponding side length of the original figure. Notice that they worded that with image first and pre-image second. That is important, that the image part goes on top and the pre-image part goes on bottom in that scale factor, in that ratio. But do note that that was the corresponding sides X, Y, and AB. Let's move on to the next part. So for coordinate notation for a dilation, you can describe the dilation with respect to the origin, which is all we're going to be doing, with the notation where the pre-image coordinate x, y gets changed to be k times x and then k times y, where k is the scale factor. If the scale factor is something between 0 and 1, you're actually making it smaller. And if the scale factor k is larger than 1, then you'll be making an enlargement, or the image will be bigger than the pre-image. Okay, so we're going to draw a dilation of a quadrilateral ABCD with vertices at those coordinates, and we're going to use a scale factor of 2. That means that k equals 2 here, and we're going to first draw ABCD, which they've done in blue, then find the dilation of each vertex by multiplying its coordinates by 2. So down here they've done all the work where A is located at 2, 1, and so then they do 2 times 2, which was the scale factor, to get 4. And then they do 1 times 2, which was the scale factor, to get 2. So L is located at twice as far away from the origin as A is. And also notice that A and L lie on a straight line, which they have to. If they're going to be a scale factor away, then they have to lie along the same line like that. B then is found, I guess M, kind of bothers me that they're not using B prime and A prime, but M, which is the image of B, is found by taking 4, multiplying it by 2, which is the scale factor again, and getting 8 for the x-coordinate, taking 1 for the y-coordinate, multiplying it by 2, the scale factor, and getting 2 for the y-coordinate. So M is at 8, 2, and notice that B and M also lie in a straight line. I didn't draw a very straight line, but you get the idea. C and N, likewise, D and P, same thing. Just multiply the x and y coordinates by 2, which is the scale factor, and you get your x and y coordinates for the image. Okay, a triangle has the vertices listed there. The image of triangle ABC after the dilation with a scale factor of 1/2 is triangle DEF. So in this case, we have a reduction. We went from the blue triangle to the red one, meaning it got closer to the origin and it also got smaller. So we're supposed to sketch triangle ABC and DEF. That's already been done for us. And then we're supposed to verify that triangle ABC and DEF are similar. Well, how would you draw the triangle DEF if this was a problem that you were supposed to work? Well, again, you'd go through the steps that we did in the last example, where you would take all of your x, y coordinates and half them, 1/2 because that's the scale factor up here. So half of 4 is 2, half of -4 is -2, and that tells us where D is. And we do that with all of the coordinates to get all of the image coordinates. And then we plot the image, and we get this red triangle here. The second part of this, though, that says verify that triangle ABC and DEF are similar. Well, first of all, we're going to notice, hey, they both have a right angle because two of the sides of the triangle are drawn on the grid lines. And we know since they're vertical and horizontal that those have to be right angles. The next thing that we need to do is, if we want to use the side angle side similarity theorem, is verify that side DF, side DF and AC form a 1 to 2 ratio, and that side EF and BC also form a 1 to 2 ratio. Well, we can do that because, fortunately, the vertices are all at intersections on the grid. So we can count this side DF as a 2 and side AC as a 4, and that reduces to 1/2, which is the scale factor. And that right there is not all of it, because we've only got side and angle now. We have to make sure that the other two sides, side EF to BC, also forms the same proportion, 1/2. So we look at that and we see that this side is 3 and that side is 6, and 3 over 6 also reduces to 1/2. So the the corresponding sides and the angle work for proportional sides and congruent angle. So we've got side angle side similarity theorem going on. Okay, and here's the work that they've done to verify that 4 over 2 is the same as 6 over 3. And really, both of those should reduce to the scale factor, which they do. One more example. You want to create a quadrilateral EFGH that is similar to quadrilateral PQRS. Well, PQRS is already there in blue. And what are the coordinates of H? My graph isn't even big enough to kind of figure out where this is, where we would even plot this. But we've got multiple choices here, and what we're going to do is try and figure out how to figure out where coordinate H is going to be. First of all, I've jotted down all of the coordinates of the quadrilateral that we know, PQRS. Here are all of the coordinates in red, and now I'm going to write down all of the coordinates for the image that I have so far. Notice that I don't have the coordinates for H, but I do have all of these other coordinates. And so the question now becomes, what is the scale factor? Well, as I go from P to E here, I'm noticing that I multiplied the x coordinate by 3. Remember that the scale factor is multiplying the coordinates, not adding or subtracting something, or not changing the signs like in rotations or reflections. So I was multiplying by 3, so the scale factor here must be 3. I can verify that with all of the rest of the coordinates. From Q to F, multiply x and y by 3, and you get the image points here. Same thing with R. So the scale factor works in all of those cases. So if I apply the scale factor to H as well, then 4 times 3 is 12, and 5 times 3 is 15, which is going to give me answer C. And so that's how you'd figure that out. You can use the coordinates that you have, look at the pre-image and image, and figure out what the scale factor is from there, and then apply that to the missing coordinate. Okay, for these practice problems that we're going to be transferring to our warm-ups, what I would like for you to do is not bother sketching the two triangles. Don't do that. What I do want you to do is to find what the coordinates of L, M, and N are. So each problem is going to have its own coordinates for L after applying the scale factor to different coordinates here. So be ready to transfer the coordinates of L, M, and N for problems 1 and 2 onto the warm-ups for tomorrow.